Hello again, Khulmani. In this video, we'll be going over the homework solutions for the work given out on the 11th of May. The first question, for the function tan of theta, theta lies between 0 degrees and 180 degrees, explain why there is a vertical asymptote at theta equals 90 degrees. So our function is tan of theta, our domain is 0 to 180 degrees. Our domain tells us the range of all angles that this function can take. So it can take a value of 15 degrees, 30 degrees, 120 degrees. Can it take a value of 200 degrees? No, because it falls outside of this range. So to understand the concept of vertical asymptote, you can relate it to the vertical asymptotes we did when we were discussing hyperbolas in the last video, and the ideas are quite similar. So I'll just explain how we get this vertical asymptote for the tan graph at 90 degrees. So 90 degrees. So we're going to look at what happens to the function as theta tends to 90 degrees from the left-hand side. So from the left-hand side, it means their values that are less than 90, and then they get bigger and bigger till we reach 90. So for example, 80, 85, 86, 87, up to 90. So in terms of our quadrants, that would mean we're in the first quadrant, angles less than 90, and then our angle gets bigger and bigger till we reach 90. So let's see how this looks. Okay, we can see that as we get closer to 90 degrees, our opposite is getting bigger and our adjacent is getting smaller. At 90 degrees on the dot, our adjacent is 0 and our opposite is the same length as our hypotenuse. So our triangle is like a flat line. Okay? So in terms of the numbers, because our ratio is opposite over adjacent and our opposite is getting bigger while simultaneously our adjacent is getting smaller, it means our numerator is getting bigger while our denominator is getting smaller, which in turn means that the whole value is getting bigger. So let's just check this with some numbers where we make the denominator smaller and smaller. If we have 1 over 1 is equal to 1, 1 over 2, 1 over a half equals 2, 1 over a tenth equals to 10. So as we're making the denominator smaller, the overall fraction gets bigger and bigger. Okay, so we can't have tan of 90. If you put that in your calculator, you'll get undefined, because at tan of 90, our adjacent is 0. So we would have opposite dividing by 0, which is undefined. So our value gets bigger and bigger, similar to how the value gets bigger and bigger in the hyperbola, and it never quite reaches 90 degrees. Okay, let's look at the other side. So as theta tends to 90 degrees from the right-hand side. So this means we've got values which are bigger than 90, say 100, and they're getting smaller and smaller. So 100, 95, 94, 93. If we depict this using our quadrants, we've got an angle which is bigger than 90, so it's in the second quadrant, and it gets smaller as it gets closer to 90. So similarly, if we look at our opposites, we can see our opposite is increasing and the magnitude of our adjacent is decreasing. So adjacent in the second quadrant is negative. So we're getting some negative number and a smaller negative number and a smaller negative number, smaller negative number, and our opposite remains positive. So if we express this with a few numbers, we could start off with, say, 1 over minus 1, which is negative 1. Now our adjacent is becoming smaller and smaller, but it's still negative. So here's a number which is smaller and which is smaller than 1 and negative. So it's 1 divided by negative half is negative 2. 1 over negative a tenth is negative 10. So we can see that overall the y values are getting more and more negative. They're getting bigger and bigger, negative, but negative. So it's like the negative branch of the hyperbola. So this is our vertical asymptote at 90 degrees. For angles less than 90 degrees, we get something like this, very big positives, and as we're tending to 90 degrees from the right, it becomes very negative. So we're going to now put this all together, as in the second question, where we plot the graph, and we'll just add in some more values. So theta, 0, 45, 60, 90, 120, 135, 180. Tan of theta. So notice I've included the angle 45 degrees. This is because tan of 45 degrees is 1. So it gives a nice whole number when we're plotting. So 0 tan of 45 is a special angle. That's 1, 60 is root 3. Remember, 90 degrees is undefined because our adjacent is 0 and we do opposite over adjacent, opposite over 0. Then we have 120. Let's look at 120 in terms of quadrants. So we're in the second quadrant at 120 degrees, and the acute angle which this relates to is 60 degrees. So in other words, tan of 120 degrees is the same as tan of 60 degrees, but our sign is negative. Tan is negative in the second quadrant. So we worked out a tan of 60 as root 3, and we just make it negative. Okay, same story for 135. It's the same, tan of 135 is the same as negative tan of 45. So it would be negative 1, and 180 is 0. So let's plot this. Tan theta, 45, 90, 135, 180. Okay, in between 45 and 90 is going to be 60, I think. No, it should be closer to 45. So it's 45 plus 15 is 60 plus 30. So it's about a third of the way between 45 and 90. And then over here, 120, it's going to be like 2/3. So let's put the values in, 1 and minus 1. Sorry, let me put it a bit lower. So this will be minus 2 and 2. So tan of 45 degrees is 1. Tan of 60 degrees is root 3. Root 3 is 1.73. So that's somewhere there. 90 degrees is our vertical asymptote. So our graph would look like this. On the other side, we've got 60 degrees. That's negative 1.7, negative root 3. 135 is negative 1, and 180 is 0. So our graph would look like this. Okay, so I hope you understood what was going on here. A little bit jumbled up, a little bit of mixing between two sections, hyperboles and tan ratios. So if you're struggling to understand, please message me, but please try doing this one on your own. Please try using the quadrants as well, just to get really comfortable with it. So that concludes today's lesson. Thanks, and have a good rest of the day.